we were done with what we were doing.
We finished like no, we have done the like Kelvin page number 7 full. Then we have to start the next like
Okay, we did we did solid to liquid and liquid to gas conversion, right?
Yes, ma'am.
Oh, okay. So basically we did that. Okay, now basically now we are done with good things. You know how you will, if you will convert solid into liquid and liquid into gas, this one is done. When you will convert solid into liquid, you know what is that process known as fusion, right? When you will convert liquid into gas, that is known as vaporization, right? But now the scenario will be reverse. Okay, if you will convert gas into liquid and liquid into solid, then what will happen? Okay, clear?
Yes, ma'am.
Okay, so basically we have to do three terms. One is your sublimation. Over here I will tell you. One is your sublimation. One is your deposition. One is your solidification, and one is your condensation. So definition you will be writing on your own. First of all, you will write solidification. Okay, just write it like this. Solidification. Just write it down, and then the definition you will write it like this, that here, change of liquid state into solid state is known as solidification. Okay, the definition you wrote for fusion, you are going to only make the changes over there. Okay, so this is your spelling for solidification: solidification. Okay, solidification, right? And then you will write the definition: change of liquid state into solid state is known as solidification.
Done, ma'am.
Next, you will write condensation. Okay, condensation, and you'll write when you convert, same definition, but what will be the changes? That over here you will write. Now you are going to convert what? Tell me.
Gas to liquid.
Yes. So you'll write over here gas. The change of gaseous state, not gas state. Okay, gaseous state. Okay, gaseous state into liquid state is known as condensation.
Done, ma'am.
Okay. Now next thing is that we'll do one more thing, which is sublimation. Okay.
Yes.
Okay. So ma'am, what is sublimation? A change of solid. Yes.
Sorry, ma'am.
It's okay. A change of state directly from solid to gas without changing. See, if you want to convert, for example, this is solid, this is liquid, and this is gas. If you want to change the thing into gas, first you need to convert it into liquid, then liquid will be changed into gas, right? But when you directly convert solid into gas without converting it into liquid, that is known as sublimation. Okay?
Yes, ma'am.
So you'll write again sublimation, then this definition, and next one is deposition. So the direct change of gas to solid and reversely also gas to solid without changing into liquid is known as deposition. Clear?
Yes, ma'am. Done, ma'am.
Now you will draw this diagram in a notebook, which is basically a quick revision. Like if you are going to convert, this is we did everything, right? So you will write interconversion of three states of matter, then this diagram. Okay.
Okay. Done, ma'am.
Now one important thing which I need to mention over here. Okay, we'll just first read this. Okay, this we have done. Okay. Now, have you heard about the solid carbon dioxide? Have you heard about this?
No.
No? Okay. So basically what is this? See, when you have a refrigerator with you in your home, right?
Yeah.
And you have an ice tray as well, right?
Yeah.
So in that ice tray, there are ice cubes. So what you do with the ice tray, basically you will fill the water, and then the next day or after some time you will say that the water which you kept, that converted into ice cube, right? But
Yeah.
yes, but in a refrigerator, the freezing one, okay. So where what you do basically over here, we have seen the ice like this.
Yeah.
Yes. So basically, see this, you can say that liquid got converted into solid. Basically, it got a conversion. But what about this air or this ice? From where it came, right? So this is the question.
Yeah.
So basically, this is basically the gaseous ice. Okay. So when you cool down the gas, okay, at high temperature, with low temperature, then it somewhere convert into solid. Okay. So this ice which is not converted, that is the ice. This is made up of CO2, and the ice, this is made up of H2O, water. Clear?
Yes, ma'am.
So this is known as dry ice. Okay, clear?
Yes, ma'am.
Okay, so over here it's just a minute. I think it's written over here itself. Okay, you can write it from here itself. Hmm. Okay, you can write it down like this. Just write it down. Just make it like this and just write H2O, normal ice, and CO2, dry ice. Okay.
Yes, ma'am.
And upper you can write when liquid get converts into solid, it will form normal ice, which is H2O. And when gas is converted into solid, okay, that will give you dry ice. Okay.
Yes, ma'am. Done, ma'am.
Okay. Okay. Now we are going to do the formula. Okay. So you know the temperature, the SI unit of temperature is Kelvin. Okay. So basically, as I told you, we have two things. One is Kelvin and one is Celsius, right? When we did about boiling point and the melting point, we did in the Celsius as well in the Kelvin form as well, right? So
Yes, ma'am.
basically, ma'am, what is the relationship between K and C? So this is the relationship that K is equals to 273 plus C Celsius, right?
Yes, ma'am.
Okay. So this is the relation. So you'll write it down the relation, then we'll do the numericals. I'll tell you how the questions comes in exam.
Okay, ma'am.
In exam hall, either they'll give you this or either they'll give you this. And if they'll give you the Celsius one, then you have to find the Kelvin. And if Kelvin is given, then you have to find the terms in Celsius one. Okay.
Okay, ma'am.
Hello, Jasleen. Jasleen, am I audible?
Yes, ma'am. Can you hear me?
Yeah, I can hear you. You joined, I think,
Can you hear me?
yeah, I can hear you. You joined earlier or right now?
No, ma'am. Sorry, ma'am. I was outside. I came home a little bit late.
Okay, not an issue. Basically, what you will be doing, you will be covering the previous part from the recording. Okay, whatever you missed
Okay.
today. And right now, I was about to start a new topic, so you will be covering the thing from here itself. Okay, just leave one page. That would be enough.
Yes, ma'am.
And that just but make sure that you cover it by today itself. Just ask for the
Yes, ma'am.
recording. We'll show you. Okay.
Yes, ma'am. Yes, ma'am.
So basically, we were about to start the numerical portion today. So this is what, as I told you that when we were doing the melting point and the boiling point, I told you that temperature can be measured in Celsius, degree Celsius, or Kelvin, K, right? So ma'am, what is the relationship between Kelvin and Celsius? So this is the relationship. So you will write the relationship K equals, make a box and write it, K equals to 273 plus C. Okay, so on the basis of this, you'll get the numericals in exam where they'll be giving you this, the value in Kelvin, and then you have to find the value in Celsius. Or they'll be giving the value in Celsius, you have to find the value in Kelvin. So we will solve the numerical, just write it down, the equation. Done, guys? Guys, can you hear me?
Yes, ma'am. Done.
Done? Justine, done?
Yes, ma'am. Finish, ma'am.
You just have to write the equation. Okay. Now we'll do the see. Over here, this one we have done. We were doing this. Okay. See, this is the question. Okay. Now they are asking convert the following temperature to Celsius scale. Okay. So you know the equation. K equals to 273 plus C. So this is given in K. Can you find the C? Both of you.
Yes, ma'am.
So find it out and let me know.
Done, ma'am.
Okay, both of you done? Done. I think Jeva, Jaslin, both of you done?
Done, ma'am.
Okay.
Yes, ma'am.
Jaslin? Oh. Sorry. Okay, so here you can see. It was very easy. 300k it was, and the equation you already know, right? So what you will do, basically you'll subtract it from 273 and you'll get the answer. Is it clear? Yes?
ma'am.
Yes, ma'am.
And similarly, you just have to subtract it, right? Just some, I'm doing, I don't, yeah. So basically it was the equation. This is given, 300k is given, right? So 273 plus C. So now if in order to find this person will be going here. So 300 minus 273, right? So whatever the answer is, you will be writing here and it will be the value of C. Similarly with this, right? So in exam hall, either you will be getting this K1 or you will be getting the C1. Clear?
Yes, ma'am.
Now the second question is, what is the physical state of water at? So tell me what will be the physical state of water at 250 degrees Celsius. So basically it will be two gaseous state. Why? Can anyone tell me why it will be gaseous state? Tell me. Just remember, yes, just scroll down your notes where you did the boiling one. Ma'am, the temperature of liquid was 15, then 25. It was rising. Then after 100, if it is more than 100, then always the water will be in gaseous state, right? But if it is less than 0 degrees Celsius, then the physical state of water will be solid, will be in the solid state, right? Yes,
Yes,
no?
ma'am.
Yes,
Yes,
ma'am.
I hope it's clear. If you check this, see the answer. The question was 250. So basically, it is rising. So after 100 degrees Celsius, mm, it start basically moving to the vaporization, right? So basically, what will be the state? The question 250. So it will rise like 105, 110, like this. 250 will be gaseous form, right? And the second one is 100 degrees Celsius. So you already know that at 100 degrees Celsius, water can exist in both liquid and gaseous form. Why? Because that is the boiling point, right? So at this temperature, after getting the heat equals to latent heat of vaporization, water starts changing from liquid state to gaseous state. So at 100 degree, you cannot say that liquid will be gaseous or liquid. It will be both because this is the state. Right now, it is being converted. For example, it is 105. Then you can easily say, ma'am, it will be in the gaseous state, right?
Yes, ma'am.
Okay, so you can just write it down. What will be the physical state of water? First, you'll write 250. Then you'll write 100 degree and then you'll add minus 5. Minus 5 degrees Celsius. So 250 you will write gaseous state. 100 you will write both liquid and gaseous state. Water can exist in both liquid and gaseous state. Okay. And the minus 5 degree you will write liquid will be in solid state. Clear?
Yes, ma'am.
And you will also write 0 degree. You will write water can exist both in solid and liquid form. Okay. So what I told you, first you will write 250, then you will write 100 degree, then you will write minus 5 degree, then you will write 0 degree. So 250 gaseous state, right? Both liquid and gaseous. Here solid, and here both solid and liquid. Clear? You will get direct question in exam hall and then you will be wondering, oh my god, what to mention. So just remember two things. Just remember this 0 and 100. If it is here in between, then it will be of course liquid, and it is more than this, then gas, and if it is here, then it is solid. Clear? If it is minus 5, it is somewhere like 10, 20, whatever it is. If it is 200 like this, I hope it's clear.
Yes, ma'am. Yes, ma'am.
Write it down, this one, and let me know.
Finished, ma'am.
Done, ma'am.
Good. Now, the very important thing, see, there is a difference between, okay, we need to do few more questions as well. Okay. Next question is, for any substance, why does the temperature remain constant during the change of state? So you already know this, due to latent heat, right? That when we convert that, for example, if you are converting ice cubes into liquid, then the temperature will remain constant. Whatever the temperature is for the ice cube, the temperature of liquid will be same. So why, ma'am? Because due to latent heat, right? So during the change of state, the temperature remain constant. This is all because the heat supplied to increase the temperature is utilized in changing the state of overcoming the force of attraction between the particles. Therefore, the heat does not contribute in increasing the temperature of the substance. So, ma'am, what is all about? So, basically, for example, if you are converting the ice cube into liquid form, right? So, if you are heating it, so, ma'am, why the temperature of this ice cube is not increasing? Why? Because the energy which is getting by heating, right? That energy is being used to convert ice cube into liquid. That's why the temperature is not using, because the energy either you can use it to increase the temperature or you can use this energy to convert. So basically you are using the energy to convert. That's why the temperature of any state is not increasing. Clear?
Yes, ma'am.
Okay. So now the next question is, suggest any method to liquefy atmospheric gases. So by applying pressure and reducing the temperature, atmospheric gases can be liquefied. So if you want to convert gases into liquid, right? So you will, by applying pressure and reducing the temperature, atmospheric gases can be liquefied. So this one you will write. You'll write hashtag how gases can be liquefied. Okay, or how atmospheric gases can be liquefied, and then you write by applying pressure and reducing. This is very important question. Okay, sometimes you miss it. So by applying pressure and reducing the temperature, if you reduce the temperature, it will somewhere turn into liquid. So by applying pressure and reducing temperature, atmospheric gases can be liquefied. Clear?
Yes, ma'am.
Do you want to write the answer for this as well?
Yes, ma'am.
Okay, because this is important question. So you can write the question for any substance why, or you can write hashtag why does the temperature remain constant during change of state, right? So this is important, very important. So just write it down, okay? And this also, how to convert atmospheric gases or how to liquefy atmospheric gases. Girls, you can let me know once done, okay?
Done, ma'am.
Done, ma'am.
Okay. Now we will do the very, you can say one of the important topics, which is evaporation. So, ma'am, you know, most of the time students get confused between vaporization and evaporation. Okay. So, do you want, like, anyone of you wants to tell the difference? What is the difference between vaporization and evaporation? No? Okay. I'll tell you. For example, this is a pond. Okay. And this is a sun. You already know, right? Evaporation will be happening, right? So have you seen that there is some kind of gaseous state, or you are seeing that okay, water is being raised up, there are some vapors? Have you seen that? No, na? No, yes.
Yes, ma'am.
You have seen any particles rising up?
Yes, ma'am.
You have seen that? Okay. Okay, who has seen?
No, ma'am.
Jeba has seen.
No,
Okay.
ma'am. Nothing.
No,
Just
okay.
me.
Jasleen said, okay. Okay, Jasleen, okay, you have seen. So how it look like, Jasleen?
Ma'am, you can feel the water, but then you can't see it that well.
Yeah, that's what I'm saying. So basically, when evaporation happens, you cannot see anything, right? But for example, this is your water bottle, cold water bottle, chilled one. Okay, you left it. Sometimes you will say the water droplets over here. Yes, no,
Yes, ma'am.
right? So basically, the droplets are vapor. So this is vaporization. When you see that liquid is being converted into, some gaseous form, right? That is known as vaporization, when liquids get converted into vaporization, but evaporation is basically the process. So in that process, you cannot see anything, right? So this is the difference. Clear? Whenever evaporation happens, that leaves a cooling effect. But evaporation basically takes all the heat up. Okay, so don't get confused between evaporation and vaporization. We'll study it, you'll get to know more about. We always need to heat or change pressure for changing the state of matter? Can some example from everyday life, when can we take some example from everyday life where change of state from liquid to vapor takes place without the liquid reaching its boiling point? Okay, so here you can see boiling point is required. You have seen now, when you are going to convert liquid into gas, you need boiling point. But over here, whenever evaporation takes place, no boiling point. You don't need to heat your pond water or the lake water, right? And for example, if you have these are the wet clothes, you don't need to heat them in order to, basically in order to convert them, like in order to just remove the excess water from them. Okay, so when this is the difference between evaporation and the vaporization. I hope it's clear now. Okay, I'll just tell you. Okay, so evaporation is basically change of liquid into vapors at any temperature below its boiling point. Okay, so for example, if you are heating this, boiling point, you already know boiling point is 100 degrees Celsius. If before 100 degrees Celsius, liquid converted into gaseous form, that will be evaporation. But if it will convert after 100 degrees Celsius, that will be vaporization. Is it clear?
Yes, ma'am.
I'm again explaining it. I know it's quite difficult, confusing. So we have two things: evaporation as well as the vaporization. Both of them, both of the things, they have the same meaning. What, ma'am? When you will convert liquid into gas, that is also known as evaporation. And vaporization, yes, ma'am. When you will convert liquid into gas, vaporation. Okay. But basically, if you want to convert liquid into gas, for example, this is your liquid. If you want to convert it into gas, okay, you need to heat it like boiling point. So, for example, the temperature was 15, then ma'am, okay, like this, 100 degrees Celsius you need. Okay. So, if you are heating it, for example, from 15 you started 15, then 25, then 35, then 45, then 55, carry on 100. So, if liquid got converted from, let's just take this 45, at 45 degree your liquid got converted into gaseous form, so then you will term this at evaporation. Okay, but if it will convert after 100 degrees Celsius, then you will say it is a vaporization. E always comes earlier than V, right? A, B, C, D, E, and V comes last. So just remember, E is basically below or before the boiling point. Below the boiling point. Your boiling point is 100, but if your liquid will get converted into gaseous form below your boiling point, maybe 45, 35, 55, 99, 88, whatever it is, then it is known as evaporation. But if it will convert after your boiling point or at your boiling point, then it will be vaporization. Clear? Guys?
Yes,
No?
ma'am.
If not, I'll explain it again. Do you want me to explain it again? Yes?
No, ma'am.
Okay. Jeba?
No, no, ma'am. I understand.
Okay. So basically now we are doing evaporation. So ma'am, what is evaporation? So you will write the hashtag evaporation. Change of liquid into vapors, or you can say gaseous form, at any temperature below its boiling point. That is known as evaporation. Okay. I'll just a minute. Don't write it down. I'll just check it if there is any definition. Yeah. From here you can write. Change of liquid into vapors at any temperature below its boiling point is called evaporation. Okay.
Done, ma'am.
Okay. If you are done, then you can make a diagram like this. Okay. This is the boiling point. This is heat. This is liquid basically. Just write it down like this. 20, 40, 60, 80, 100. Okay. So here just write evaporation, and here write vaporization. So you'll get an idea that if it is this is a boiling point. Okay, right, 100 boiling point. So if it is below the boiling point, then it is evaporation, and if it is after the boiling point, above the boiling point, or at the boiling point, then it is vaporization.
Done, ma'am.
Finished, ma'am.
Okay, good. Now we'll do the most important topic, which is you must have observed the rate of evaporation. Now, first thing is that factor affecting evaporation. Okay, so there are various evaporation. So for example, these are the clothes. Okay, right? These are the wet clothes. This is your terrace. Okay. So, for example, if you are going to dry them up, of course, evaporation will be taking place only then they will dry up, right? So, for example, there are various factors that you are going to tell me. First, wind. Just tell me if wind speed is high, then evaporation will be faster or slower.
Faster.
Okay. Second is your surface area. Surface area. Surface area means, for example, here you are keeping all the clothes congested and here you are keeping them like with a little gap. So with surface area, what will happen? What will happen? Evaporation will increase or decrease.
Increase.
Okay. Third is temperature. If it is too warm, then what will happen? Your clothes will dry faster or later.
Faster.
Okay. Fourth is humidity. If it is humidity, your clothes will dry faster or later. Not sure about humidity, right?
Later.
Okay. Good. Like, so I am very confused between the voices, like both of you. For voice, I need to check who is speaking. Maybe after few classes, it will be fine. I can make a difference. But right now, it's not possible. So, okay. So now, basically, there are various factors which affect the rate of evaporation. So, like affecting evaporation. So, first is basically surface area. So, when evaporation increases, when there is increase of surface area. Second, increase of temperature. When temperature will rise, your rate of evaporation will increase. Third, wind speed. When your wind speed will rise, then also your evaporation speed will increase. And next is humidity. It is opposite. When your humidity will be low, only then your evaporation will be rising. Clear?
Yes.
So
ma'am.
now, first of all, you will make notes, then we'll write the detailed one because in exam hall, you will be getting direct question where you have to explain all the factors. So first you will write the notes, then we'll do one by one the explanation. So you'll write factor affecting, you'll write hashtag factor affecting evaporation. Okay. Then you will write increase in evaporation, increase in rate of evaporation, increase in rate of evaporation. First, increase of temp. This is increase basically. If you want to if you want to make arrow, you can. If you want to write it down like the whole one increase, you can. So when rate of evaporation will increase, when surface area increases, when temperature increases, when wind speed increases, but humidity decreases. Clear?
Ma'am. Done.
Done? Both of you?
Yes.
Now you must be wondering, ma'am, as you told us that below the boiling point evaporation takes place. So why it is like this? Okay. So basically what happens, for example, this is a beaker. Water particles are there. Maybe some particles will be high. Some particles will be low. Like they have high melting point, some will have high boiling point and low boiling point, right?
Yes.
Okay, Justine cannot see my screen. Okay, I'll just stop sharing. I'll just share it again. Justine, can you see my screen now?
Ma'am, it's loading.
Okay. Let me know once you can see my screen. Okay, no problem, Justine. I'm just not explaining anything. Okay. I'm just explaining a little thing, then I'll end the class because we are done with the time as well. So I was just giving you a reason that why, ma'am, it's like that below boiling point it takes place. So basically, for example, if this is a water particle, all of the particles are basically they have low boiling point. So of course, before boiling point itself, they will melt. Oh, sorry, they will convert into gaseous form. So because the particles water contains, they have either high or low boiling point. That's why it's in evaporation. If, for example, I have only low particles with low